Now we're zooming in on a pancreatic beta cell. What happens in the beta cell is extremely important. You know, within a beta cell, glucose is basically able to come into these cells via a glucose transporter. Then once taken inside of the cell, it undergoes anaerobic metabolism and then aerobic metabolism to produce ATP. These ATP molecules then bind to potassium-sensitive channels that are sensitive to the ATP. And when ATP binds, they close. Now, when these channels close, potassium can't exit. Potassium builds up inside of these cells and creates a positive charge inside the cell that activates voltage-gated calcium channels. These calcium channels open and calcium rushes into the cell and stimulates these vesicles that contain insulin and stimulate insulin release. In addition to that, there's also an enzyme called glutamic acid decarboxylase. This enzyme converts glutamic acid into GABA, and GABA is another molecule that is associated with the stimulation of insulin production as well as protective effects of these beta cells. Now, let's apply the antibody concept here. When antibodies attack our tissues, they attack specific self-antigens that are present on our pancreatic islet cells. And these antibodies, which is high yield, are called anti-islet cell antibodies. The second set of antibodies are targeted against this glutamic acid decarboxylase, and these are high yield, called anti-glutamic acid antibodies. The last one is that there's antibodies directed against the insulin, and these are called anti-insulin antibodies. Now, as these antibodies attack the beta cell or the proteins within it, what happens to the beta cell activity? Well, these antibodies start destroying the beta cells. And as there's decreased number of beta cells, what happens to their insulin production? It starts dropping. What's the problem with that? That can lead to high blood glucose. How? If we look at the cellular level, let's follow this insulin as it binds onto a particular cell. Insulin binds onto what's called insulin receptors and triggers an intracellular cascade that increases the expression of glucose transporters on the cell membrane. And then what happens is that allows for glucose to come into the cell and effectively decrease blood glucose levels. That's the effect, to decrease the blood glucose levels. But if this insulin production is decreased, what happens to the increased expression of GLUT transporters? It drops. If we decrease glucose transporter expression, what happens to the glucose entry into the cell? It's inhibited. If glucose can't come into the cell, what happens to the glucose levels in the blood as a response to that? It starts to rise. And that is the effect of type 1 diabetes.